Example 4.1. The compression gravity axial loads for a building column have been estimated with the following results. D equals 150 kip, live load from roof LR equals 60 kip, live load from floors L equals 300 kip, compression wind W equals 112 kip, tensile wind W equals 96 kip, seismic compression load equals 50 kip, and tensile seismic load equals 40 kip. Determine the critical design load using the ACI load combinations. In other words, for the critical design load, we are to determine the maximum or the load combination which will generate the maximum result. And before we solve this problem, let us first define what are load factors and load combinations. Load factors are numbers almost always larger than 1.0 that are used to increase the estimated loads applied to structures. Why do we have to increase? Because there are some uncertainties involved in estimating their magnitude. And the total required strength, or U, or the ultimate strength, should be a combination of all those loads and load factors. Okay, but not to add all of the loads, because it is impossible that all of the loads will attack or will have an effect on the building at the same time. For example, it's almost impossible that there is a typhoon and there's also an earthquake at the same time. So therefore, wind load and earthquake loads are separated from each other. They are not combined in one load combination. Okay? So these are the standard load combinations set forth by the ACI. Now, through experiments and statistics, they were able to coin these load factors and load combinations. So let us make use of this and solve for the maximum value. So we make use of this and then solve individually the load combination. However, if you try to look at it, there are more load combinations here as compared to this. It's because there are positive and negative values for wind and earthquake respectively. Because wind can either be compression or tension, as well as seismic. Now, why is that? For example, if you have a building and you have a wind force attacking in one direction, it will produce compression on the windward roof. But it will also produce suction on the leeward roof. So, wind force is not automatically pushing but also suction. The same with seismic, because seismic is back and forth movement. So therefore, there might be a chance that it's compression, and there is also a chance that it will be tension. So I have listed down all the possible load combinations based on these given loads. Okay, so all you have to do is plug in all those values. For example, we have 1.4D. So that will be 1.4 times 150. And you have 210 kip. Next, we have 1.2 dead load plus 1.6 live load plus 0.5 of roof live load. So the answer is 1.2 times dead load here, 1.2 times 150 plus 1.6 times roof live load, 60. We don't have snow or rain load. Then plus L or 0.5 W. So L is simply live load and this is 300 kip. And obviously, L is greater than 0.5 of W, because W is only 112. So we make use here of the L. So the answer is 690 kip. Alright? So just substitute all of these values here to the different load combinations, considering the positive and negative magnitudes. Okay, so try to use your calculator. You have here above the given loads and this one load combinations, and try to use your calculator and solve for all of the values of the different load combinations. So these are the values, and among all these values, what is the maximum? And that is what we are looking for as the critical design load. Now, by inspection, you will notice right away that 690 kip is the maximum. So let me make this one into a bold character. So that will be your answer already, 690 kip. For those who are using Microsoft Excel, the formula is max, meaning the maximum of all these values. So the maximum is 690 kip. Okay? Thank you very much.